Hello, Keith Rucker here at VintageMachinery.org. Guys, today back to working on my new 30-inch Thompson grinder, new to me. We've been in the process of doing some light restoration work to it, mostly cosmetic up to this point. We're going to be getting into some other things here in a little while. Basically, what we have done is we have taken this machine in the shop. We have pulled off pretty much everything that we could pull off of it. We stripped the paint off of it. I got a new fresh coat of paint on this thing. I'm happy with the paint job. I mean, it's not showroom quality as far as like a car or something like that, but more than adequate. We stripped things off, did a little bit of body filler on it, not too much, just the worst things, and gave it a coat of paint here and just using rattle cans. This is a Rust-Oleum dark machinery gray paint that we got on here. What I'm going to be working on today is we're going to be starting to put this machine back together. And the first thing I want to tackle is the electrical components. Now, I took pretty much all the electrical stuff off to get the paint job done. I have come back in here and put the main electrical box back on. It still has the original components in here as far as transformers, motor starters, and so forth. I did disconnect all the wires that go to the individual motors and stuff like that, but the panel that's in here pretty much is as it was originally when this thing was shipped from the factory. And we're going to be double checking a few things to make sure that everything's wired up correctly. And then we'll be, I think, putting new conduit or flexible conduit, new wires going to the motor starters, to the motors and to the starter buttons and all that kind of stuff. And that's going to be working on here today. First thing that I've got to tackle though is that this machine, as delivered from the factory, was wired for 440 volts. Now, my shop that I'm running here, I have a rotary phase converter that's powering this, and I'm running on 220 volts, three-phase in my shop off of my phase converter. Again, this was wired for 440 volts. Now, one option when that kind of a situation comes up is very often you can come in here and change the wiring on your motors and convert it from 440 volts to 220 volts. Most motors have 9 leads coming out of them. Depending how those leads are tied together, you can set it up for either the high voltage or low voltage. One of the motors, and this machine does have multiple motors. There's a spindle motor. There's a motor for the hydraulic pump, which is not over here right now. I've got it over there. And there's also a motor for the coolant pump. Everything on here had dual voltage motors on it originally. However, one of the motors had been rewound at some point, and when it was rewound, the motor shop that did that did not pull all 9 leads out. They only had the 3 lines coming out. It was wired for 440 volts, and short of having that motor rewound or replacing that motor, there is no practical way to get it on the low voltage option. So my options were I could rewind the motor or change the motor, or I can step the voltage up on this 240 to 440 volts, which is the option that I'm going to. Down here on the floor in front of me, this is a transformer. I picked this up. This is basically just this is a multi-port, multi-tap transformer, but it has the ability to feed it 220 volt 3-phase, and it will convert that to 440 volts. It's just the same way the power company does it. You put transformers in to step voltage up and down all the time, and that's exactly what we're going to do with this. We're going to give it the 220 volts. We'll give it 220 volts at 30 amps, and that will change that over to 440 volts. The amperage, since we're doubling the voltage, the amperage will go in half, so that'll go to 15 amps. But at 440 volts, the 15 amps is more than enough amps. I did the math to run all these motors. So that is what we got. This is a 15 kVA transformer. I picked this up from American Rotary, the same guys that I got my phase converter from. They do also sell transformers. They don't make them there like they do their rotary phase converters, but they are a dealer for them. I contacted them, told them what my needs were, and they were gracious enough to find what I needed and get that to me, and I purchased it from them, I'll be honest with you. But this is what we're going to be putting on here. Now, as far as the transformer is concerned, I could just put it in the shop and have some 440 volt outlets, put it over, mount it on the wall or whatever. I think what I'm going to do, because pretty much everything in my shop is 220, I want to keep the machine where I can run it on 220. And I've been looking for a place, where can I mount this? There's actually room right above this electrical box. I'm gonna put some little strips of metal on here to mount this to, and we'll then basically feed it with the 220 volt. It'll convert that to 440 to go into the panel here, and that's what we're gonna be doing. Today, what I wanna do is get the transformer mounted, get the transformer hooked up, get the voltage checked out. And if we have time, we may start running some of our conduit and wires to the motors and to the motor starter buttons over here to kind of get everything hooked back up into this so that we can control things and hopefully get this machine where we can get it powered up for the first time since I've had it and just kind of check everything out. So not sure that we'll get all that done. That's a lot to tackle in one video, but we're gonna get started on this. This may turn into a multi-part video depending on how long it takes to get this done. I've done enough talking. Let's get started. We're going to get this transformer mounted up here on the machine. So I took the top off of my transformer here, and there's a diagram on the front that kind of shows the different taps that go into this transformer. So this is a multi-tap transformer. It's capable of doing all kinds of different voltage combinations. Some transformers are just wired to go 220 to 440. This one will go all kinds of input voltages to all kinds of output voltages, including 220 to 440. The catch is you got to know which wires to use in here, because each one of these wires goes to a different tap on that transformer. Now, basically, they're divided into 3 different groups. This is for your 3 different phases that will go in. And we will be using one of these wires for the input voltage at 220 volts and one of the wires for the output voltage at 440 volts for each phase. And I've already figured out we need to basically be using, coming in on X, let me look here, it's H4 and X4, I believe is what it is. All right, so here we go. This is my first leg. I'll be coming in on X4, and we'll be coming out on H4. Why the difference in the size of the wire? Remember, we're doubling our voltage. We're reducing the amperage by 1/2. So 30 amps in, 15 amps out. So smaller wire on the smaller amps. It's carrying a higher voltage with smaller amps. Same thing over here. So, these are the ones we'll be using. These wires will not be used at all. And I am just going to take some electrical tape and tape up all these caps real good. That way I'll know that I'm not using them, and that'll also make sure they don't come off. So let me go grab some electrical tape, and I'm just going to go ahead and do that. They're not going to be connected to anything. They're just extra as far as we're concerned for this installation. All right, so we've greatly simplified things here. I've got the wires that we're not using. We got the wire nuts taped on so they won't come off, and I also kind of just bunched them up together in 3 different groups here where they're out of the way, out of sight. We're only going to be using these 6 wires in this particular setup, so the rest of these are clearly kind of, like I said, they're just out of the way, out of sight, out of mind. So these are ready to go. I left these undone. We'll tape these up once we get the leads tied into them. But what we need to do now is get this thing mounted up on the machine so that we can start working on things. We're going to mount this transformer right up here. I've made a couple of brackets that I'm just going to bolt over here to the machine itself that we can then mount the actual transformer onto. I need to drill and tap some holes in here. These need to be 3/8 16 holes. I've got them marked out. The ones on the ends will actually hang the transformer on and tighten it up. And I got another one here. It's just countersunk, and that will just give me a little bit of leverage. And then the third bolt be out here will just go through and hold them in place. Got a cordless drill set up here with a 5/16 inch drill bit, which is the drill hole size for 3/8 16. And we're gonna drill a hole in this cast iron for a bolt to go into. Probably ought to take a peek in there and make sure I'm not drilling into anything important. I'm not. I am drilling into a web though, so it's probably not going to go all the way through. That should be plenty. Get the one up above it. deep enough. Take a little anchor lube, put a little dab on my tap, and go ahead and tap this out. All right, that's in the bottom. Put a little more dab of anchor lube on there, and we'll tap our other one here. All right, that's in the bottom. I'm just going to snug these up in place, get them leveled up and get them spaced properly, and then we'll locate where the holes for the countersunk screw will go. And we'll drill and tap those as well, but I need to get those positioned properly first. All right, those should be where we want them. So I've got a transfer punch. This punch is the same size as the hole that we got drilled in there, 3/8 of an inch. So that should put that hole that I'm drilling right smack dab in the center. And that'll work. I think I'm just going to go ahead and drill these in place. There's no reason to take them back off. So we'll just go ahead and do those. And I've got a flathead screw here and my piece countersunk, so I'll screw in there, hold it in place, and it'll be below the surface on this one, since this will be behind the transformer. This one will actually hang on it, and we'll hang one on this side as well. All right, I'm gonna get the same thing done down here on the bottom, and I think we'll be ready to put our transformer on. So I've got my transformer here hanging from my gantry crane, not my gantry crane, but my engine hoist rather. And trying to get it kind of positioned where it needs to be. We can get our holes lined up there maybe. Here's one screw started. Apologize, I'm probably in the way of the camera here, but there's just no place else to set things up. All right, I'm just got it kind of loosely in place. Let me get the other side going. I need some nuts to go on back of these. Now I'm going to let the pressure off of this. Kind of let that settle in place where it needs to sit. And we'll tighten those up. I think we're good. I think we got it mounted. Got the transformer mounted. Everything looks good up here. Next step is I want to get a disconnect put on here. Now, This had a fuse disconnect on it when I got it. I am changing it out just because the one that was on here was kind of ratty looking. I'm sure it probably worked just fine. And I dug around and I had this disconnect here over in my stash of stuff. This is not a fuse disconnect. This is just a straight disconnect. But really, I don't need a fuse disconnect. I've got the breaker in the fuse box that should give me protection. And of course, we have protection on the motor starters and stuff in here. So the fuse part, I'm not too worried about. I just want to have a physical disconnect going to the machine. Now, the original disconnect was mounted right here on the side of this box, kind of like this, and I think that's what we're going to do with this one as well. So I'm going to need to drill some holes to get this mounted, and then we can start doing some wiring. So let me figure out where I need to get some holes put, and we will get this thing on there. I want to make sure this door will shut, and it does. So we are good. All right, I think we're ready to run some conduit and run some wires. So here's the game plan. The power is going to come in to this box from the bottom. We'll have 220 volt, 3-phase coming into the disconnect. From the disconnect, it's going to go up. It's going to come out of this knockout here on the side. Let me knock that one out. I've got a 90-degree bend here with some waterproof flexible conduit. We're going to come right into the side here. Whoop. All right, so we'll come up from there, and we're going to just come right up the side. There's another knockout right here on the side of this box, and we'll come into the transformer with the power right here. Knock that knockout out. And again, we'll put one in here with a 90-degree bend in it. Go ahead and slide this up on here. Here, it needs to be cut off right there. I'm just going to use a little multi-tool here, hopefully. Cut that in two. That should work just fine. Now we need to run some wire through that line. Kind of catching folks up here where we're at. I've done a little bit of wiring and stuff off camera, and I've pretty well got the transformer wired in. So power comes in. I've got just a plug in here. This is a cord that's rated for 30 amps that comes in, and we'll just plug this into our 3-phase power circuit here in the shop. This will be 220 volts, 3-phase, 30 amps. Comes into the disconnect. From the disconnect, I got a switch there. I can easily shut things off. And the main thing I've got this for is I'll probably leave, you can use the plug as a disconnect. You can unplug it. That is disconnecting the machine. But this way I can leave my plug plugged in and turn it off right here easily, so that the transformer's not just sitting here running all the time, or maybe not, it's not energized all the time when I'm not using the machine. When I get ready to use the machine, flip it on, the power is going to go from here into the transformer. Again, 220 volts, 3-phase coming in. In the transformer, this is a step-up transformer, at least that's how we have it wired right now. We're coming out at 440 volts coming into the main electrical box here, and that's what everything in here was designed for, and that's what everything is wired for. Again, the transformer up here, I'll mention that I sourced this again from American Rotary, the folks that I get my 3-phase converter from, and they helped me get the right one size and whatever. I'll also mention, and in all transparency, they're a sponsor of my channel. I did pay for this one, by the way, though. But if you're interested in phase converters, anything like that that you get from American Rotary, they do give my viewers, you guys, a discount. So you can get a 10% discount if you will use the checkout code Vintage10. So if you're looking for a phase converter or anything along those lines, even I think their hot shot ovens are included in that deal. So you can get a 10% discount from AmericanRotary.com just by using the checkout code Vintage10, and that gives you a 10% discount. Just throwing that out there because I know a lot of people take advantage of that, and they've been really good to work with me on stuff like that. Let me come around the other side. I'll kind of show you what's up next as we move on here. So coming from the transformer, we come into the power box back here with all the electrical components. This has got my motor starters and transformers for the starter voltage and all that. And I really didn't touch any of this. This is pretty much just like it came from the factory. I've got to do some work over here with this transformer. I got to get that figured out in a bit. But basically what we got is we got the coming in down here, the 3 wires, L1, L2, L3. This is all 440 volts. And it's going right into this motor starter. That's how the original one was wired up. And then from there, that is going to take the voltage to the other places in here. I have, again, not touched anything other than putting the 3 hot wires in. And also have my panel grounded up here in the top. I don't know if you can see that or not, but it is. We got ground. It's grounded in the box here. It's grounded in the transformer, and then it's also grounded into this box. And trying to make sure we got everything up to code and like it needs to be there. What's next? Inside this, we're controlling multiple things. So we've got a 3-phase motor that does the spindle on the machine. We have a 3-phase motor that's driving the hydraulic pump on the machine. We have another 3-phase motor for the coolant pump on the machine. And let's see, what else is there? There's a powering the magnetic chuck. I think that's just 220 volts or 440 or whatever it is. It's not 3-phase. Then there's also a lubricator on here. And that's actually what this transformer does, is get the power step down for the lubricator. And that's whenever the machine is on, it's just constantly cranking out some lubrication on a time there a little bit. Got to get all that wired in. I'm going to do this just one circuit at a time. I'm going to start with the spindle motor. We'll bring the wiring in. We've got a block over here where all that stuff comes into. And I think number 1, 2, and 3 will be the ones going to the spindle. So I'm going to go ahead and get that wired up next. So this is a spindle motor, and I've got some conduit, some flexible conduit running up here from the panel that we were just in coming into this. I replaced all this. This is pretty much what was on here before, but it was kind of getting kind of ratty looking. So I just opted to go with all new conduit and things. But right now, what I got to worry about is tackling this rat's nest here. This is the wires that come out of the motor. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 leads that come out of the motor. That's typical on a 3-phase motor. If it's a dual voltage motor, you will have 9 leads coming out of it. And depending on how you tie these leads together, will give you the option to run the motor in either the low voltage option, which is 220 volts, or the high voltage option, which is 440 volts. And obviously we're running on 440 volts in this situation. Right now, the previous owner had come into this and he had changed the wiring around for 220, so I kind of got to undo that and get it back to the 440 option. While I'm in here though, if you'll notice some of these wires that has the cloth on them, we've got frayed wires, we've got exposed wire and all that. What I'm going to do is one at a time, I'm going to come in here on each one of these, and I'm going to be putting on some heat shrink tubing over these wires. And once I get them installed, I will get out my heat gun and we'll heat shrink all these in place. So basically I'm replacing the insulation on here. All these wires are also numbered 1 through 9. This is number 4, that's number 6, this is number 5. It's hard to read them, but I'm on there. I've got some little heat shrink labels I'm going to put on here as well and renumber each one of these wires as we're going along so that we have good insulation and we have the right number on there. Once we do that, I'll tie them together as they need to. There's a diagram over here on the back side of the motor that shows how they need to be wired together for the voltage that we're going to be giving it. I'm also going to be taking off some of this electrical tape and stuff that I guess somebody had put in here before, trying to fix some of this. We're going to just basically get all this cleaned up and make sure we don't have any wires that short out. So let me get to work on that. Well, this electrical work is always kind of slow, but we got this done. I got all my wires, new shrink wrap on them, so we shouldn't have any wires to short out in there. I've actually gone ahead and brought my line wires in. That's the blue, black, and red wire here. These leads are just tied together in the motor, and didn't have enough of the fancy little clamps on, so I just used some regular wire nuts on these three. But I'm gonna put all this back up inside the pecker head and seal her up, and we'll try this motor out here in a minute once we get the switch wired in. But this should be ready to go. Well, guys, giving a quick update on the Thompson grinder. Been working on the electrical work, and I'm saved you guys a bunch of the tedium that's involved in that. You know, how exciting is it to watch people install conduit and pull wires and connect them? You know, if you're interested in learning how to do electrical work, there's probably better places to go to than me trying to show you. I have shown, you know, some basic stuff in this, but really just want to kind of hit the main spots of what we've done here. So first thing I will say here is that, yes, we have moved the machine. This is where I want it to sit in the shop. It's kind of in the back of the shop, kind of in my grinding area where I do a lot of my grinding at. I had my old Thompson grinder basically sitting in the same vicinity, although it was directly across from this. I have moved some things around a little bit to make things fit a little bit better. I've got it sitting on the floor now. It's not up on wooden blocks anymore. It's actually sitting on some metal disc on the ground to kind of spread the weight out on the concrete. So this is where it's going to live, and we've got it pretty much hooked up and basically running. Didn't really change any of the wiring inside the box at all. It was all original to the machine. However, pretty much all the wiring that came out of the box going to the different components we replaced, and I put everything in new flexible conduit. This is all waterproof, fluid-proof conduit going everywhere, flexible hose, this kind of gray stuff. And I did put new wires and all that just because, hey, I was cutting new conduit, might as well just put new wires in there as well. Got the spindle motor here. So there's a motor that runs the spindle. There's a motor that runs the hydraulic pump on the back. There's a motor that runs the coolant pump on the side. And technically there's also this oiler here on the side, and there's voltage that goes to this. I won't say there's a motor in there, although there is. It's a very small motor, but this is something that's going to automatically inject oil up onto the ways of the machine. It's just, I think it's on a timer. Every so often it just puts a little squirt up there. I will note, interesting thing here, when I got this, the plastic tank on this lubricator was broken. There was a hole punched in the side right here where something had hit it. And you know, when I got in the shop and I noticed it, I remembered a long time ago, a viewer sent me a tank to go on a Bajur lubricator. I had no use for it at the time, but I put it up on a shelf, and sure enough, it fit perfectly. I don't even remember who that sent it to me. Whoever it was, thank you very much, because we were able to put a new reservoir on this oiler. I haven't put any oil in it yet. It is wired up into the thing, so whenever we turn the machine on, it starts pumping oil into the ways here. There's 2 places here, 3 places where the oil kind of squirts up underneath the table that goes back and forth. So I guess what there is to do now is I'm going to plug it in, and we're going to fire it up and show you that everything's working on here. So there is a start-stop stations down here with start-stop buttons. There's 2 buttons on here, even though there's more motors than that. We have one for the spindle and we have one for the hydraulic pump. Now, when I turn the spindle on, it's going to turn on the motor here. So you'll see the spindle actually spinning up here. It's also going to turn on the coolant pump. Now, I will note that I don't have any coolant in the tank right now, so that coolant pump is running a little bit noisy. I don't want to run it for very long because it needs to be pumping fluid, and I don't have anything pumping on it right now, but we will run it for just a second. The other button in here is for the hydraulic pump, And when you turn it on, you'll hear it kick in. I'll probably do it separately, and that's the hydraulic pump. Again, I don't have any hydraulic fluid in the machine right now. It's completely drained, so I don't want to run it very long there. I also have, when the hydraulic system turns on, it starts pumping the oil over here, because the hydraulic system is what's going to move the table back and forth. There's a hydraulic cylinder in here, and that is what moves the table back and forth. So anyway, we're ready to go. We'll start with the spindle and coolant pump. There you go. Our spindle is running. Our coolant pump is running. We'll go ahead and knock those both off. We'll let those spin down just so you can hear it. I'm real happy with how the motors sound. I will say, and again, I probably should have filmed this, but I just was in a rush to do it. When we hooked up the coolant pump, turned it on, and I was listening, trying to figure out if it was running in the right direction and everything else, and all of a sudden, everything shut off. And I realized that the overloads had tripped on the coolant pump, and got to looking, and the bearings in the coolant pump were just frozen up. They had gotten some moisture in them, just rusted out. So I took the coolant pump motor apart and replaced the bearings in it. They're like brand new now. That motor's running just fine. So like I said, probably should have shown that on video, but I was just going to rush to get it done. All right, we're going to fire up the hydraulic pump. And again, I'm just going to run it for just a second because I don't have any fluid in there, but it's running. So good news is all the electrical stuff checked off the list. We are good electrically, and I feel much better about this machine now that I've seen the spindle run. I was just concerned about that. I was told it worked. Still haven't seen the hydraulics on it work, but there's no reason for me to believe that they won't. So once we get some fluid in here, we'll get that checked out a little bit down the road. As the hydraulic fluid, as I had mentioned in a previous video, this thing takes 60 gallons of hydraulic fluid. I've still got to get that sourced and in the shop. But before I fill the tank up with hydraulic fluid, which basically the whole bottom side of this casting is a giant hydraulic reservoir. So all this area up in here has hydraulic fluid in it. But before I fill it up with fluid, I do want to take some time and get this machine checked. First off, I need to get it leveled up, and then I need to come in here and I need to check the ways and see if we need to do any scraping or any touching up on it. I suspect we're going to touch it up, but until I get a chance to get a straight edge on here, run my Kingway alignment tool on it, and just really assess how much wear is in these ways, I'm not going to say 100%, but more than likely we're going to come in here and do some scraping on it. Might as well while we have it apart. And I'm hoping that it's not too bad and we can get it touched up pretty quickly. Why do I want to do that before I put the fluid in there? Well, when I'm scraping, I'm going to be chipping off little pieces of cast iron that can go down into this open reservoir up underneath it. I don't really want to be contaminating my fluid with any kind of trash that comes off of this. So I'm going to get it scraped in first. Then I'm going to get in there and clean the bottom of that tank out really good. Again, it's already been cleaned. But clean it out real good again, make sure I got everything out of there, and then we can put the table back on and probably fill the hydraulic fluid up will be the last thing we do with that. And that's going to probably be coming up, the leveling and inspection of the machine, and if necessary, any scraping, that's going to be coming up probably next on this particular project. Got most of the parts and pieces that we took off the machine back on the machine, at least that we can do right now. There's some stuff that goes on the table and stuff. I'm going to wait until that goes back on to get that done. But for the most part, everything's pretty much back on here. We got a few little odds and ends, but yeah, we're doing good. But yeah, coming along nicely. The machine, I'm real happy with how it looks. We're not running yet, but I'm happy with how everything has gone so far. So I think it's going to be a good machine. All indications are pointing toward this being a good grinder. And I think by the time we get through scraping it in and getting it all set up, it should be running really, really nice. And of course, we'll regrind the table, regrind the magnetic chuck, and get everything really tuned in nice on this before we're all said and done. But making progress. And with that, it's going to be a wrap. Guys, as always, thanks for watching. Please subscribe to the channel if you haven't already. Thumbs up and comments, always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. Big, huge thank you to the supporters of the site who support by subscribing, as well as through Patreon and PayPal, helping out financially, which is really, really helpful and allows me to take the time to do these videos and share them with you guys. And with that, guys, we're going to sign off, and we will catch you on the next video. Again, thanks for watching.